Welcome to today's edition of Math Dive in 5. Today we'll be focusing on three-dimensional figures. I'm Barbara Knox.
And I'm Daryl Frost. Welcome.
On the next slide, you're going to see a variety of three-dimensional figures, and I want you to think about how you could place those figures into just 2 categories, into 3 categories, or into 4 or more categories. Think about the attributes that you have to use in order to make each of those sorts, and sometimes you might have to use more than one attribute. So happy problem solving. All right, here you see the progression with BEST. They're identifying three-dimensional figures in kindergarten. They sort them based on size and orientation. They're limited to spheres, cubes, cones, and cylinders in kindergarten, and they'll do also rectangular prisms in first grade.
And I see there, Barbara, there must be something wrong with this slide because I don't see second, third, and fourth on here about 3D figures.
Daryl, in second, third, and fourth grade, they're only focusing on two-dimensional figures. So students aren't going to see three-dimensional figures from first grade all the way to fifth grade. So
well, they do see them in first.
They see it in kindergarten and first.
But not again until grade 5. So this is an interesting benchmark because it's not like linear. Every
Correct.
grade level, they're learning something new.
But they are learning what they need to know about two-dimensional figures to be successful with the three-dimensional figures.
So it kind of builds in that sense.
Yeah. And they will be classifying three-dimensional figures into categories based on their defining attributes. And you see all of the shapes that they're limited to there on the slide. The next several slides are going to take those shapes that you sorted from your initial task and looking at some of the ways that they've sorted. Daryl, how do you think that the shapes on this slide are sorted?
Well, I see 8 different categories.
Yes.
Because there's 8 different groups, correct?
Mm-hmm.
All right. Well, the first one in the upper left, those are all, they don't have any faces.
Right.
So that we call those spheres.
Correct.
I believe. Okay. And then I see that the group in top, if I look at them as rows, in the middle, those are, they all have an apex, which is that point at the very top.
Correct.
And they have one face. We could call those cones, is another vocabulary word. And then we have cylinders with 2 faces, top right. And then we have second row to the far left, I would call those triangular pyramids.
Correct.
They're triangular because their faces are triangles.
Because their base is a triangle.
And their base is a triangle, and they have come to an apex.
How many faces do those have?
They have 4 faces.
So on this slide, we have sorted them by the number of faces.
So it's the number of faces as a very broad category, but we also have subcategories based on the number of faces. Am I saying that correctly?
Here we have another sort. This time we only have 3 categories. Daryl, take just a minute. Think about how these might have been sorted.
Well, right away, now you said 3 categories. It's actually there are
3
groups.
3 groups.
But they're sorted by one category. Would that be? So so the category or the attribute they're sorted by would be the number of bases.
The number of bases. So I have 3 categories. I have 0 bases, 1 base, and 2 bases.
But also, because there's so much vocabulary involved in these geometric benchmarks, when you look at that category, the category in the upper left are spheres. The category in the upper right are pyramids, which
They're
includes.
not all pyramids. I see cones also.
Well, there's cones, But the pyramids all come to a point or an apex.
Correct.
As opposed to the bottom left are all prisms.
Yes, and the prisms and cylinders.
Yes.
All have two bases.
Two bases, yes.
Yeah. One thing to note too about the cones and pyramids is that a cone has an apex, but that apex on a pyramid is also a vertex.
It's a vertex, yes.
Because edges come together to make that point.
And prisms and pyramids are named by the shape of their base.
Correct. So if I'm looking at a pyramid that has a pentagon on the bottom, it's a pentagonal.
It's a pentagonal pyramid.
Mm-hmm.
Or a prism, if it happens to be a prism.
Here we have another sort. Lots of different groups in this sort. What do you think, Daryl?
Well, I still think it's about the bases, but this time I think it's not the number. I think it's the shape of the bases.
Correct. So I have, for example, the cylinders and cones are all together because they have circular bases.
They have circular bases, and then the far right are pentagonal bases, yes, because the base is a pentagon.
Correct.
You also have triangular bases because, again, the shape of the base is triangles, and then in the middle there, those are all square bases.
Yes.
Rectangular bases to the far right, it's only got one in its group. And then you have hexagonal bases in the far left.
Correct. Mm-hmm. Here is another sort. You looking closely, Daryl?
I am. Let's see, we've talked a lot about bases.
And
faces. So another attribute are edges. So I'm thinking that edges, and I'm just looking at that top left, which has a lot. And it's interesting because many students will say, and I've actually heard teachers say this, curved edges, but the definition of an edge is that it connects two faces.
Correct. And that circular surface, that curved surface is not a face.
It's not a face. So that top group there in the far left has 0 edges.
Correct.
And then the others are just based off the number of edges that they have.
You are correct. This has been sorted into just 2 groups.
Well, right away, I think this was a little bit easier sort. I mean, I see all those cones and pyramids together, and they all have an apex,
yes,
and none of those prisms to the left have an apex.
So on the left, we do not have an apex, and on the right, we do have an apex. All right, Daryl, what have we sorted by on this slide?
Well, as I look at how the 3D objects are grouped, I'm going to say by vertices because I see the 3D objects to the far left and they have no vertices at all. So I'm going to say by vertices.
Yes, you are correct. And you can see the triangular pyramids have 4 vertices.
Yeah, cones have 1 vertex each, those cones that are there.
Yes, and you're going to have some conflicting information with cones. If you look at different math resources, you'll find some resources that say a cone has 0 vertices. You will have other math resources that say a cone has 1 vertex.
Well, what does best say? Because I would think that's where we want to go.
Talk about in the next slide.
Oh, okay. So, Barbara, you mentioned on the previous slide that there's some conflicting information on resources out there that we as teachers use about a cone. Can you tell us more about that?
I'm going to talk to you about what we have in the best glossary and in the best Big M document for grade 5.
Okay.
So in best, that top screenshot you see for vertex comes from the K5 glossary. The point at which the rays they meet and form an angle, right?
Right, yes.
So if we look at the high school definition of cone, there is no definition of cone in the elementary glossary, but in the high school glossary, you can see that a cone is a 3-dimensional figure with an apex that is connected to the base by a collection of line segments that form a curved surface. So because it has line segments, it would also have to have angles that form that vertex.
Okay.
So that's the definition that we're going with in Hillsborough County, in the state of Florida, really. And this comes from the Big M document in grade 5. Yes. This is an instructional item.
I've seen this.
So we don't see the word vertex, we see the word apex, which is what I think they'll be using for assessment purposes. It's that furthest point from the base.
Okay. So an apex is a special type of vertex.
Correct. Here's our final sort. What do you notice about all those shapes on the left that the ones on the right do not have?
All the shapes, all the 3D figures on the left have a curved surface.
Yes.
I didn't say edge, a curved surface. The 3D objects on the right do not.
You're absolutely right. And the cylinders have both, and cones have both a curved surface and a flat surface.
Yes.
Right, they have a plane surface as well. In 5th grade, students will be focusing on right rectangular prisms and cubes, which are similar, but the faces are going to be all squares on a cube.
Yes, and when we say right rectangular prism, that means it only has right angles.
Correct.
So that's important to understand what that means. But look at all that vocabulary there.
Well, and some of the attributes that kids are going to focus on are the faces, edges, and vertices, the shape of the bases, and how many bases they have, and whether or not they have curved surfaces.
Lots of vocabulary.
We have spheres and cylinders.
So I'm looking at this here. This is from STEMscopes, correct?
This is a STEMscopes resource.
So according to the definition of a vertex, which you just shared, which is best, and what we need to be thinking about, this is not correct. That should say one vertex.
Exactly. So, I mean, you just need to know going into your resources that you might find some conflicts when it comes to cones and vertices.
So we just have to be mindful of that.
And we have pyramids. So be thinking about how you would name the pyramids. If we're naming them by their bases, what would this one be called, Daryl?
A pentagonal pyramid.
And here's a triangular pyramid.
That would be a pentagonal pyramid.
A pentagonal pyramid.
A square pyramid.
A square pyramid. And I believe a hexagonal pyramid.
We also learn about triangular prisms. Here's an example, triangular prism. What we want 5th grade students to know is that there are 2 bases on a prism, and the rest of the faces would be rectangular in shape.
Correct. And again, they're named by their bases. So the triangular prism that you see on the left, then we have the hexagonal prism, a pentagonal prism, an octagonal prism, and another hexagonal prism. With our concrete representational abstract thinking, we want to keep in mind that students need to touch and feel these 3-dimensional objects. Yeah. Starting with the real world objects, you see dice, a basketball, a can, a box, and then transition to those pictorial representations, which are basically 2D images of a 3D figure. When we see those 2D images, we can't see the entire shape. So we're seeing the front of it, and we might see little dotted lines that kind of show us what's in back, but it's hard for students to visualize that.
They have to touch it.
And then your abstract thinking, where you're talking about the
vocabulary
of the 3-dimensional figures. Thank you for joining us for this edition of Math Dive in About 5.
See you next time.